Today's video lesson is for lesson 6.1, Powers and Exponents. Our learning target today is for you to be able to represent numbers using exponents. Another word for represent would be to write numbers using exponents. So at this time, please open up your textbook to page 433 and get ready to go. So let's start with our vocabulary. A product of like factors can be written in exponential form. So exponential, if you look at that, has a root word right here in exponent, right there. Okay, so that's our root word. Exponential form means we're going to have exponents in it. And that requires us to have an exponent as well as a base number. The base is the number that's used as a factor. Remember, factors are what we take times each other. There are flashcards, like 2 times 3. The 2 is a factor and 3 is a factor. The exponent then tells us how many times that base or that factor is used repeatedly. So let's go ahead and fill in the boxes with the words factors, exponent, and base. Go ahead and try it on your own and then turn on the recording when you're ready. So the tens here are our factors. So they are, our factors. The 10 then is our base. And the 2 tells us that I have 2 sets of 10 multiplied by each other. So that's our exponent. So they ask you to give another example of an exponent. I will write down one, and I'd like you to come up with your own. So if we had 4 to the third power, that's the same as saying that we're taking 4 times 4 times 4. So then in this exponent, 3 is the exponent. Why don't you come up with your own answer to add to that line as well? So the definition of an exponent, it is the exponent tells me how many times I should multiply the base number times itself. So let's take a look at this example over here in the real world link. MP3 players come in different storage sizes, such as 2 gigabytes, 4 gigabytes, 16, and even now with our smartphones, 32 gigabytes on the iPhone 6. So GB means gigabyte. 1 gigabyte is equal to 10 times 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 10. So how would we write this as our with an exponent? It would save us a lot of time than writing that all out. So the base number is 10, and now I have to go back and count how many 10s I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 10 to the 9th power, which, if we had to write it out in standard form, would be a 1 with 9 zeros behind it. So what's nice about exponents is they make our writing shorter. For example, what if I had to put this number into a story multiple times? It would be a lot easier just to write it in exponential form with that exponent. It would shorten things up for me. So today we're going to be working with writing products as powers. Numbers expressed using exponents are called powers. So for example, 100 is a power of 10 because we can write it as 10 to the 2nd power, because that would be the same as saying 10 times 10, which we know would be 100. Oops, my pen gave out, sorry. Numbers like our 100 just happen to be perfect squares because they are the squares of whole numbers. So here we have 10 by 10, that's a perfect cube because we're using whole numbers. If we were to use a decimal, for example, like 1.3 to the second power, this is not a perfect square. But this is a perfect square. If we happen to go ahead and make a perfect cube, notice over here I only had 2 dimensions, so that's why it was squared, 2 dimensions, the length and the width. Now when I take the length, the width, and then I add in the height, we get a 3-dimensional figure. So this is called a perfect cube. Sorry, that my C looks like an E. And that we can also work for a number like 4 times 4 times 4, which is 64. That's a perfect cube. We're taking 3 things times it. So a non-example would be if I took 7.32 to the third power. This is not a perfect cube, because it's written as a decimal. So let's take a look at how do we write our exponents. Number 1, we have 6 times 6 times 6 times 6. The 6's is our base, and then we count up how many there were. There were 4, so 4 is our exponent. So we would say this is 6 to the 4th power. So let's look at number 2. We have 4 times 4 times 4. The factor that repeats is 4, and we multiply 4's by itself 3 times in a row. So the exponent will also be 3. So we will write it as 4 to the 3rd power. All right, why don't you go ahead and try writing these with your as exponents. Pause the recording and turn it on when you're finished and check your answers with mine. In this first one, we have 7 as our base, and there are 1, 2, 3, 4 of them, so 7 to the 4th power. On our next one, we have 9. And there are 1, 2, 3, 4, 5, 6, 7. So it's 9 to the 7th power. To write powers as products, we have to determine and know what the base and the exponent is. So the base of 10 to second power, or 10 squared, is 10, and the exponent is 2. To read powers, consider that exponent. The power 10 to the second power is read 10 squared. Just like when we saw it on our area, if I said that area is equal to 14 feet, we always said it squared. We didn't say to the second power. And if we were finding volume and their answer was 27 feet to the 3rd power, we would say 10 or 27 cubed, or feet cubed. So we will do the same then when we're reading 10 with the exponent of 2 as 10 squared, and 10 to the with the exponent of 3 is 10 cubed. So let's look at example 3. They would like us to write 5 squared as a product of the same factor and then find the value. So the base is 5, the exponent was 2, so 5 is used as the factor 2 times. So we'd write 5 times 5, and that's equal to 25 then. On number 4, they'd like us to write 1 5/10 cubed as a product of the same factor and then find the value. The base is 1 5/10, so the exponent is 3. So 1.5 is used as the factor 3 times. So we put out 1.5 times 1.5 times 1.5, which gets to be 3 375 thousandths. So at this time, calculators are okay in this chapter. Then on number 5, they say write 1/2 cubed as a product of the same factor. And we don't have to sweat this because we just spent a lot of time in chapter 4 multiplying fractions and dividing fractions, so we know what to do. We'll take 1/2 times 1/2 times 1/2, which we could rewrite then as 1 times 1 times 1. Oops. Made a goof here in the middle. over 2 times 2 times 2. And we know that 1 times 1 times 1 is 1. And now here you have to be careful on the bottom. A lot of kids skip ahead and just go ahead and write 6. But 6 is incorrect. If we were adding these up, we would get 6. But it's 2 times 2, which is 4, times 2 again, which makes it 8. So our answer is 1/8. And so be careful up here. A lot of kids will write down 4.5 on this one because 15 times 3 is 45. A lot of kids put 45 on there, but that's not true because we need to take 1.5 times 1.5 and then again by 1.5. So here they would like us to write each power as the product of the same factor and then find the value. If you'd like, go ahead and pause the recording and try all three on your own using the examples above. Otherwise, just follow along with me. Here we want 10 is my base numbers, and we're going to multiply it by itself 5 times. So what's nice about powers of 10, we simply really have to write down the 1, and then the exponent tells us how many zeros to put behind it, because here I have 1, 2, 3, 4, 5 of them. And then I just have to put my commas in. So that 10 to the 5th power is 100,000. On this next one, we're going to take 2 and 1/10 times 2 and 1/10. So I'm going to ignore my decimals and just do 21 times 21. 1 times 1 is 1. 2 times 1 is 2. Hold my place value. I'm done multiplying by the ones column. 2 times 1 is 2, and 2 times 2 is 4. Add it up, and we get 441, and I had 2 decimal places before, so I'll have to have 2 decimal places back here. So my answer is 4 and 41 hundredths. And on this next one, we're going to take 1/4 times 1/4. And we can't simplify that with the cross products at all, so 1 times 1 is 1. 4 times 4 is 16. So 1/16. All right, let's take a look at some here in a story problem. The zoo has an aquarium that holds around 7 to the 4th power gallons of water. Okay. About how many gallons of water does the aquarium hold? We're not really estimating, even though we see that word about. It's because they said it's around. They don't know an exact number. So we're still actually computing and finding the actual answer. So 7 to the 4th power would be 7 times 7, which is 49 times 7 more. And at this point, you can have your calculator out. So 49 times 7 more equals 343 times another 7, the 4th one, and we get 2,401. So the aquarium holds about 2,400 gallons of water. So why don't you try this next one, and then turn on your recording when you have it. So we take 10 times 10 times 10 times 10. So we can put down the 1, and then I told you the exponent on a 10 always tells you how many zeros. So we can count them, 2, 3, 4, just like what the exponent says. So we're going to have 4 zeros behind it, and then we put in our comma. So it's about 10,000 lakes. So go ahead and get your practice assignment from the board or from your teacher. Good luck, and if you have questions or you're struggling, please make sure you come and get help.